So, essentially, for transformations, what you're checking to see is how an object moves. The objects we'll be working with are straight lines, but if I had this circle, there's 2 or 3 things it could do. It could slide. It's a transformation. So if this circle slides, and let's say the equation of a circle was x squared. Let's say that's the equation. If it moves up, then we're just going to add. We're going to add the number of units that it moves up. This one happens to move up 1, so the new equation is x squared plus 1 for this circle. If it had moved down, the original equation is x squared. It moves down, let's say 2. Say 2 units. So it moves down 1 and 2 units. Then we just subtract the number of units. So this transformation is called sliding. You're just sliding. The other transformation is something called a dilation. That's where you get bigger or you get smaller. So if it's a dilation, let's say it got 2 times bigger. So my new equation would be 2 times x squared. It's getting 2 times bigger. That means it expands. Or it vertically stretches. It gets taller. It does get wider. Now, let's say I want to divide it, or say 1/2 times x squared. If I multiply by this fraction or a decimal, it gets smaller, or it vertically shrinks. It gets shorter. So those are the 4 things we're going to do today. What you're going to need are the highlighters in front of your desk. Take them out. You're going to get your entry stitch. Okay, so we call every function, every straight line has a parent function. Every straight line has a parent function. Every linear equation has a parent function. A parent function is the parent's form, or the basic form of a function. A parent function is basically the basic form of a function. All linear functions have one parent equation. Every other form of that function is a child of the function. It is a child of the function. Now, the parent function of every line is y equals x. It is an equation. Y equals x. We're going to graph that equation without the use of a calculator. We do that by identifying the slope and the y-intercept of y equals x. Now, what is the slope? What is the number in front of x when there's no number there? It's 1. It's 1. So my slope is 1. How do I make that in rise? Put that in rise over run form. 1 divided by 1. Now, what is the y-intercept? Is there a number added to 1x? So what is the y-intercept? What is b equals 0? So we're going to start at 0, and then we're going to go up 1 and right 1. So start at 0. You go up 1 unit, then you go right 1 unit and make a point. And you keep going, and what you're going to do is create a diagonal going all the way through this graph. All the way up, it literally splits it in half, right? This is the parent function. We're going to create this line. If you got your graphing calculator, you can use that case. You can put it up to these points and go from the bottom to the top or the top to the bottom, depending on how you want to do that. And we need to label it. We need to label it so we know that this is the parent function of all linear equations. This is the basics of how all linear equations are formed. This is y equals x. And that's what the equation is called. Now, certain things happen when you multiply numbers times that x term. If you multiply big numbers, numbers that are bigger than 1 or -1, these numbers vertically stretch a line. The transformation that's happening is a vertical stretch. That means this line is going to stretch upwards and inwards towards the y-axis. It's a vertical stretch to y. Okay? But we're going to get the slope of each line, the y-intercept of each line. So looking at y equals 2x, what is the slope of y equals 2x? 2 over what? 1. You always divide by 1. There's no number there. What is b? What number is added to 2x? 0. There's no number there, so it's 0. So for this y equals 2x, we're going to start at 0. And our pattern is to go up 2 and right 1. So stretching by 2, this new point goes up 2. So I go up 1, 2, and then right 1, make a point. From there, I go up 1, 2, then right 1, and make a point. And I keep going until I get to the end of this graph map. Now, going backwards, I go down 2 and left 1. Down 2 and left 1. I'm going the complete opposite way. If you look at your new line and highlight it yellow, highlight it yellow. It's highlighted yellow. So we know we've created a vertical stretch here. It's gotten closer to the y-axis. We've created a vertical stretch. Now, the bigger this number, the more it increases towards the y-axis. The steeper it gets. The steeper it gets. We're not going to graph all 3 of those equations. Just the top one. Now, moving on. We're going to graph, let's graph y equals 1/4 x. What is the slope? Here it's 1 over 4. I'm not going to graph these. Too many lines on one paper. What is the y-intercept for 1/4 x? 0. 0. So you start at 0. You go up 1 and right 4. Up 1 and right 4. Right? So I'm starting at 0. I go up 1, right 4. 1, 2, 3, 4. If I want to go backwards, I go down 1 and left 4. Down 1 and 1, 2, 3, 4. Create my line. And if you notice, this equation, I'm going to write the equation name, y equals 1/4 x. It vertically shrinks 4 units. It does something called vertically shrinking. Vertical shrinking. So, try and answer the question here. It says, what happens when the value of the slope increases? Here it's 1. What happens to the line when it increases to 2 or 4? It vertically stretches. It vertically stretches. You're right. It vertically stretches. That's going to be a question on your test. It vertically stretches towards the y-axis. Next question, it says, what happens when the value of the slope decreases?
Vertically shrinks.
Perfect. It vertically shrinks. You guys are going to do really well on the test. And in Algebra 2.
Towards x-axis.
Towards the x-axis. If you can understand this, you can understand anything. Okay? Now down below, the parent function of a line, it's repetitive. The parent function of all lines is always y equals x. Your slope for this line is 1. I want to create a fraction, I divide by 1. My y-intercept is 0. So we're going to graph the parent function. Again, you need to be able to do this like that. So I start at 0. I go up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. And keep going until I create that diagonal that splits this graph. Create the diagonal that splits the graph. This is my parent function of all linear functions. The difference between these graphs here and these graphs up there is that these numbers are all negative. They have a negative slope. However, the same thing occurs when the number is bigger than 1, even if it's negative. If it's bigger than -1, or technically smaller than, you vertically stretch. Okay? Right here, these are my vertical stretches. But down here with these fractions, we're vertically shrinking towards the x-axis. So we're going to pick 2 things to graph here. So the things we're going to graph y equals -4x. We're also going to graph, let's graph y equals, turn your phone off, -1/6 times x. So looking at y equals -4x, what is the slope of that line? -4.
-4 equals like downward.
-4.
4 downward.
M equals -4 divided by 1. What is your y-intercept? 0. So you make your point at 0. The directions that you're going down 4, right 1, down 4, 1, 2, 3, 4, right 1. If I wanted to go the opposite direction, you go up and then left. So up 4 from 0 and then left 1. If you notice, it looks weird. It crosses over that line in the opposite direction, but it's still steeper. It's gotten closer to the y-axis. It's just for flipped over. Flipped over and closer to the y-axis. But down here, if I were going to do the y equals negative 1/6 times x, m equals negative 1 divided by 6. b equals 0. Now, I go to where I have my y-intercept at 0, and my directionals is down 1, right 6. The opposite direction is up 1, left 6. So down 1, right 6. And here I am. Up 1, left 6. And there it is. Let's go back and label these equations so we're familiar. This is y equals negative 1/6 times x. And this is y equals negative 4x. Answer the questions below. Almost done, guys. Answer the questions below. So this is what happens when the value of the slope increases. What happens when it's bigger than 1, even if it's negative?
It virtually stretches towards the y-axis.
Same answer. Same answer. Like I said, if you can do this, you're going to do good. The line vertically stretches more and more as that number gets bigger. It vertically stretches more and more. The next one asks you again, what happens when the value of the slope decreases?
It virtually towards x.
Towards the x. Perfect. First one is towards y-axis. Second one is towards the x-axis. Okay? Almost done. Right? So our next, those were dilations. Those were things that were stretching, and those are things that were shrinking towards these axes. Now we're going to see what it looks like to slide up or down. I'm not going to go over left or right. That's an Algebra 2 concept, but I kind of wanted you to see it. It is just easy stuff, right? So up and down. Up is always a positive direction. Why are you turned around? Stop. Up is always a positive direction. Down is always a negative direction. So either you're going to move up and add a number to that term, or you're going to move down and subtract a number. Now, to reiterate, a parent function is the basic form of all functions. I'm very repetitive. Every other form of the function is a child of the function. The parent function of all lines is y equals x. I want to graph the slope of this line. M equals 1. Divide by 1 to get rise over run form. B equals 0. Graph your parent function. Graph your parent function. And then we're going to look at the slide. Slides are easier sometimes than other transformations. So parent function start at 0, go up 1, right 1, up 1, right 1, all the way up until I make that diagonal all the way up and down the center of this graphing map. So here's my parent function. It is y equals x. Now, it's called y equals x. Look at y equals x plus 3. What is the slope of this line? 1. M equals 1. What's the y-intercept? 3. What did I do? If I add a number, am I shifting up or down? Up. It says up. How many units? 3. Now you have two options. You can just graph the equation, or you can pick two good points. I'm going to pick, let me fix my line here. I'm going to pick, just fixing the line. Two good points. So here's a good point, right? And it doesn't matter. Here's a good point. Now, basically what the shifting implies is every point shifts up. The whole line shifts up 3 units. You pick two good points and shift them up 3 units. So 1, 2, and 3. Here's my y-intercept. I go to the next point on the red line. Shift up 3 units. 1, 2, 3 from the parent function. My new function is this line. It's parallel to it, but it's y equals x plus 3. Now, if I was going to write this in words, if I asked you for you to write this in words, you would write shifts up 3 units. That implies for x plus 5, you shift up 5 units. That implies for plus 1, you shift up 1 unit. We're not going to graph these particular equations, though, right? Almost done. I'm not going to graph those particular equations. But that's how you describe it via words. We have the algebraic, which is what's given, the equation. The translation in words is right here. Graphically, we've already done. So the next one we're going to do is y equals x minus 5. What is the slope of y equals x minus 5? 1. What is the y-intercept? -5. Now, we always start at our parent function. It's y equals x. If I'm subtracting 5, am I moving up or moving down? You're shifting down. So let's write the verbal translation, which is to shift down 5 units. Next, -3 means to shift down 3 units. For x minus 1, I shift down 1 units. Okay? Like I said, we're going to do the first one. So we already have our good points, those 2 black points on that red line on y equals x. Moving down 5 units, I have 1, 2, 3, 4, 5. Here's my new point. For the next one, 1, 2, 3, 4, and 5. There's my new point. And these are all parallel lines because they all have the same slope. But this is y equals x minus 5. It's got a y-intercept at -5. And it's shifted down from the parent function 5 units.
That's it.
Answer the questions below. It says, what happens when the value of the y-intercept increases? What happens when you add a number? It shifts up. Write it down. It shifts up. What happens when the value of the y-intercept decreases? It shifts down. Good. So it shifts up and it shifts down. So before you put things up, I want to go over some of the homework for tonight. We're not going to do this page. We don't need to do it. This is an Algebra 2 concept, and we're doing straight lines only, so we're not going to do that. But do turn to the homework number 4. Do turn to the homework number 4. All right. So it says the function f of x is shown on the coordinate plane. Does anybody know the name of this line? Says the function f of x. It is called f of x. We don't have an equation for it. This is the equation that we have. It's called f of x. It's very important that you understand that. All right? Now, is this function shifting up or is it shifting down?
Up.
How many units?
1, 5.
Where are you getting 1 from? Let's read it. It says plot 2 points on the grid to create the graph of the line that represents f of x plus 5. How many units does it shift up by? 5. Read through the entire thing. The reason I'm going over that is because I know you didn't read through it. So even though it tells you what it's doing there, you're going to write it. Shift points up 5 units. When they say f of x, they're implying this line moves up 5 units. So I picked 2 good points. I always like 0, 0 if it's there. Right? So shifting up 5, I go up 1, 2, 3, 4, 5. Unfortunately, this point I picked is not a good point, so I'm going to pick a different one. I'm going to pick one down here somewhere. I'm moving up 5. I can't move past that. So, shifting up 5, I have 1, 2, 3, 4, 5. My new line is f of x plus 5. This is f of x plus 5. So I'm going to ask you about the next picture. Finish that up. That's the answer. That's your transformation. You just transformed the line by sliding it up 5 units. Now look at this next graph. It says the function g of x is shown on the coordinate plane. Plot 2 points on this grid to create the graph, the line that represents g of x minus 2. Now, what is the name of this line? G of x. You guys know this. You can read it now. You understand the concepts of math language. What is it doing? Is it expanding? Is it
Shrinking? No.
shrinking? Is multiplication.
It's going down.
It's going down.
Shifting down.
It shifts down. G of x shifts down 2 units. That means I'm going to pick 2 good points and move them down. Here's a good point, and here's a good point. All right, so I say 1, 2, create my points. 1, 2, create my points. And my line looks like this. This is called g of x minus 2. So we're going to do one more, right? So this number 3 is very much like number 4. All right. So they're asking for a new equation. They want the equation of the new line. Now, is this slope going to be positive or negative? Positive. So we're going to eliminate some things. That new line is not going to be y equals negative 3x. This is a negative slope. Eliminate some things. This line is positive. My new slope is going to be positive as well. Now, it says if the line graph below was shifted 3 units downwards, which equation would best represent the line shift? He's saying it's C. So how do you know? We can check the y-intercept. Let's move down 3 units. What's the new y-intercept? Move. Start at the y-intercept. Move down. 1, 2, 3. What's this new y-intercept? 1. It's 1. It's 1. Here I have a y-intercept of 1. This is the correct answer. Easy stuff. Look at number 4. Look at number 4. Here's my original y-intercept. Is this slope positive or negative? Positive. Can I eliminate anything yet? Nope. They're all positive. Now, it says the shift is 5 units upwards. What's the new y-intercept? 1, 2, 3, 4, 5. New y-intercept, I have b equals 2. So, yeah. All right. On the back, you do have more homework. Things I need you to do. If you have not done math space, you need to start it today. All of the homework in the packet needs to get done. You have a unit review to do the next class, and then you're taking a test. So Tuesday, Unit 5 review. Thursday, Unit 5 test. If you need to take the Unit 4 test, please schedule that with me before we break for December. That's it for today. That was a video.